Hello, everybody. Welcome to another video for the Introduction to Machine Learning workshop. So in the previous video, we've covered decision trees and understood the intuition behind Gini impurity, right? So in this video, we're going to be showing decision trees in action. So the way you use a decision tree is first you need to import the tree library in sklearn from sklearn import tree. We're going to build a decision tree classifier to, classify if a person survived or not. And we're going to use max leaf nodes as 8 to limit the amount of leaf nodes, so the amount of kind of dead ends in the tree. And we're going to fit this classification tree to our data XY, right? So we're fitting to the data. Normally you want to actually fit to the X train, Y train, but we'll fit to the whole data. But you in the real world, you should actually train your classification tree by fitting to X train, Y train, right? And use the test as an evaluation, right? But anyway, let's do good practice right now. And we run this cell, right? And we see here, this is what our tree looks like, right? So we see here, okay, for the male, right? Is the value of male, is the passenger a male or not? And if so, you go in one direction or the other. And likewise, you see for age, okay, is age a number less than this, right? If so, proceed on this branch, otherwise go on this branch. Is the P class less than negative 0.82? If so, go on this branch or otherwise go on this branch, right? And you can see the Gini impurity kind of, you can see the Gini impurity changing like as you head toward the leaves, right? So essentially these are the leaves right here that your decision tree is predicting. And this is how, the decision tree is making the classifications, right? So that's essentially what our decision tree is doing in terms of a classification model. And you can play around with max leaf nodes and other parameters to see how well you can get this decision tree to be. But that's kind of essentially a brief intro that you really need. So the next model is called logistic regression, right? So let's understand what a linear regression model is. So a linear regression model is essentially taking, a bunch of points and essentially kind of plotting the best fit line, right? So for example, you want to use height to predict weight. So plot the data, right, in a grid and then kind of draw a line that kind of best fits the data and follows a trend, right? But logistic regression has a similar spirit to linear regression, but you use discrete values instead of continuous values. So linear regression is good for predicting, say the price of a house, but logistic regression is good for saying, does the email contain ham or spam, right? So logistic regression can help predict discrete values, right? So luckily, sklearn has this already built for us. We import logistic regression, we instantiate an object, right? And then we're going to call .fit on our X train, Y train. And we see here that we get our logistic regression object right here. And we're going to take predictions on the X test. So we'll see what does our logistic model regression predict for if a person survives or not on the Titanic. And this is our predictions array, by the way. And we can probably compare the predictions you get here against our Y test to see how good did you do. I'm going to leave that to you as an exercise to be able to write a function that does that. But usually sklearn has this function for you to score how well your model did. So that takes care of logistic regression. The next type of model we're going to talk about is neural networks. So imagine if we want to develop an algorithm that can just learn any function and build super complicated models from a large amount of data. Neural networks are really great at doing that, and they're eventually the starting foundation for deep learning, which will be our next workshop. This link here is very helpful in playing around with neural networks. So you can essentially kind of drag and drop features right here. We can add different hidden layers. We can you can play around with these and kind of hit run and kind of see how's your loss changing and how's your neural network classifying. So I implore you to play around with the simulation. I think it's really good to get a basic intuition. But anyway, we import our neural network classifier called MLP. MLP stands for multi-layer perceptron, and we'll go into the detail in the next workshop. So we're going to instantiate our neural network, fit our X train, Y train, and kind of score how well did the neural network perform on our training test. We'll see here that in our neural network, we used 3 hidden layers, each with 3 neurons. And if we add more hidden layers, we want to see if the model becomes simpler or complicated. And if the model becomes more complicated, is that necessarily a good thing? I leave that to you to think about. Till then, we're going to continue with survey of models in the next video. See you in the next one.